Hello. Can you hear me?
Yes, sir.
All right. So, yeah, we before we go into the summary, let's do the trees. We have not. So we have to learn how to use because based on what we have learned so far today, is very okay. So how do our pairs? Any idea? Hello.
Sir, your voice is breaking a lot.
No idea.
Sir, actually, I could not hear
Here,
the
let me
question
come back.
because your voice was breaking.
Okay, 1 second. Can you hear now?
Yes, sir, it's better.
Is there noise? Is there noise?
No, sir, it sounds clear.
Okay, fine. Yeah, so my question was, how do we represent trees? We are going to do tree data structure. Yeah, we haven't done almost all the exercises we have been doing involve list. So let's do trees so that in the coming weeks we can use questions on trees and also in the quizzes. So how do we represent trees using our trees in Lisp? Particularly like binary trees. How can we represent? What is an idea? Anybody? Saina? Devyani?
A list of list or
Yeah, we can use list of list. So here is an idea. Uh, a node of the tree will be a list which will be of the form node left subtree right subtree. Yeah. So for instance, if I have a tree like 1, 2, no, let's make it 0. Yeah, let's make it 2. 3, will be as 1, then what?
Pair of 2, 3.
Pair of 2, 3. How does that work? Because we have to do inductively, no?
So 2, 3 would be subtree. So 2 comma nil and 3 comma nil.
2 comma. So let's look at this tree 2. 2 will be represented as 2 and 2 empty list because there are no subtrees. Yeah. Similarly, 3 will be represented as 3 and 2 empty subtrees. There won't be anything. And then 1 will be like this. Yeah. So this will be that tree 1, 2, 3. 1. Then one's subtrees will be the tree which contains just 2 and the 3 which contains just 2. Yeah. Clear? Is there a encoding clear? Hello?
Yes, sir.
Okay. So then let's try to create the tree and then I'll give you some exercises. Okay, so if I want to create a tree, let's create a tree. Define, make tree. We are going to be very simple. Okay, we are not going to put some tags and things like that. We're just going to be very simple. So if I have if I want to define a function make tree and then a value v and left subtree ls and right subtree rs, this will be what will be this make tree. So if I have already a tree which is left subtree and a tree which is right subtree, and I want to create a tree which contains v at the root and left subtree ls and right subtree rs, how do I create this?
It's a list of V, LS.
rs. Yeah. So basically what I'm doing is that I'm just creating a list which contains v and then ls on the left and rs on the right. That's how I create my tree. And if I have a tree, so let's also write the associated functions. So if I have a tree, then the root of that tree will be root of that tree will be
Or char.
char of tree. And similarly, if I have a tree, L tree, left subtree of tree will be, let's call it ls. Left subtree of that tree will be char of cadre of that tree. Yeah, it will be the second element of that tree, which is named char of cadre of that tree. Similarly, right subtree of that tree will be char of cadre of that tree. Yeah, so we have written 3. So if I take root of make tree of v comma ls rs, it will be v, and if I take ls of make tree of v ls rs will be ls and so on. So that will be the contracts. Okay. All right. So now let's write an insert function. If I want to insert an element x, so let's write 3 on the left and x on the right, so that we can later on we can do some tricks. if I want to insert a tree, insert an element X into a tree, what do I do? I'm going to start. If tree is null, so I need to check null tree of tree is just checking if the null of tree. So if I want to insert an element X into a tree, and if the tree is null, what should I return?
It should be a list with X nil nil.
Yeah, make tree X nil nil. Now, otherwise, what do I check? Let's do binary search tree. Okay, we are doing binary search tree. So, what is the property? If the element X is less than the root value, then I insert on the left subtree. Otherwise, I insert on the right subtree. Get it? So, if the element X is less than root of tree, the element is less than a root of the tree, then what do I do? What should I do? Who is going to answer that? Anusri? Anusri? Kasher?
Sir, is that insert to the left subtree?
Yeah, insert to the left subtree. So what should I write here?
Insert ls tree.
Insert ls.
ls tree x.
Now, okay. So if in that case, what will happen?
In that case, it will take the
If
left subtree. Yeah, it will call this function again, sir, right?
Yeah, it will
With the
call.
left subtree.
But ideally, what do I want? Ideally, I want to return a tree. My tree insert function takes a tree and returns me another tree where the X is inserted. You get what I'm saying? My insert function initially when I give it with an empty list, it returns me back a tree with X inside it. If I give a tree with X inside it, then I should get back a tree with another value inserted. Yeah, you understand what I'm saying?
Okay, sir. Yeah.
So what should I do here? I should reconstruct the tree with X inserted. Isn't it? So basically what I should do is that I should reconstruct the tree and make tree, then root of tree, and insert on the left subtree, and right subtree. Everybody understood this step? Is this step clear to everybody? What I'm doing here? My insert function takes a tree and gives me back, returns me a tree with where X is inserted. So I'm programming functionally now. That is why I have to recreate the tree because I don't have states. So after this we will do with the states. Yeah, where we do set Q and all these things. So right now what I'm doing is that I'm taking a tree and I'm returning a tree with X inserted. So therefore, if the root of the tree, if the X is less than the tree, what I should do is that I should make a tree with the same root, but with a left subtree where the X is inserted, and the right subtree as in the original tree. Okay. Is this step clear to everybody? Nidish?
Yes, sir.
Okay, so
Yes.
then tell me what should I write in the next line?
So if the X is greater than the root of the tree,
Yeah, but I can also write sharp T. Says that in the general case, in the other case, yeah, because there is only one more case left, and that is this. So whenever it is true, what should I write?
yeah. So whenever this is true, we have to make tree of root of tree, LS tree, and insert on the RS tree.
Okay, so and that's it. That's the insert function. So now if I do insert, and what should be empty tree? So let's call it empty tree. Empty tree is nothing but nil. Insert nil 1. You get 1. Now if I insert 2 to this, I'll get an error. So what is wrong? Application, not a procedure.
You have not called insert actually.
Yeah, insert nil 1 2. Okay, so now it's inserting. So let's try once more. One, 0, 2. That's correct, yeah. So it's correct. It's yeah. So that's how we inserted. Yeah. So now I want to. So if I want to insert a whole list into a tree, what should I do? What can I do? Hello. Hello. So who can answer me? How can I in one step insert a list into into this tree? How?
Sir, list means subtree, right?
No. I want to insert 10 elements into my tree, but I don't want to write in. We can use it using our fold operation. You remember what is the fold operation or the reduce operation? Or it was called accumulate, no? Hello. You remember what is the fold operation? Somebody remember?
Yes, sir.
Yeah, so I can use the fold operation to insert a number of trees because number of elements into my tree. Because if I have a list of, let's say, I'm going to use reduce, because reduce is the name which Python uses, for instance, for folding from the left. So reduce empty tree, e tree, reduce insert e tree, then empty, then if I give supply a list like 1 2, let's write it like this: 5 1 4 2 3. So if I write like this, what should happen is that I should get back a tree which where it starts with the empty tree and all these elements are inserted. That's what I want to write. So what is our reduce operation? It's just the fold left, which is so reduce a function f, a value v, and a list access will be if null access, then you return with the value v. Otherwise, what you return is reduce with the same function. Now you apply f, v, and char of access. You apply f with v, the original initial value and the first element of the list, and to that you apply char of access. So now if I do this, what happened? Something wrong.
I think that E tree that you defined
Yeah.
is actually enclosed in a. Is that will that not? You should just do define E tree nil, right?
Ah, why did I put it in this one? That was not a function. Yeah. Yeah. So now I have inserted. So now everybody understood what I did with the reduce?
No, sir.
You remember this operation called fold left?
Yes, sir.
So what does fold left does? If I have a list like 1 2 3 4, and if I have a function f and a value, let's say 0, how does the fold left function work? First I apply 0 and 1, I take and I apply f. Yeah. And then to
Yes, sir.
which I take 2 and I apply f again to these two. Yeah. And so on.
Yes, sir.
This is what is my reduce operation or fold left operation. This is exactly the operation I have to apply if I want to insert the elements 5 1 4 2 3 to a list to my tree, which the empty tree. What do? I take the empty tree and I insert empty tree and 5 with insert. Then I take that value and I insert 1 and that tree which I just created, I do the insert operation again and so on. Is that clear?
Yes, sir.
Okay, so if I do this 5, 1, 4, 2, 3. What should be the tree I should be creating? I should be creating 5 should be the root. Then comes then comes 1. So 1 is inserted here, and then comes 4. So 4 will be inserted to the right. 4 will be inserted to the right. Then comes 2. 2 will be inserted again to the left of 2, left of 4. And then comes 3, which will be inserted to the right of 2. So this will be the tree we get. So this tree will be 5 and left subtree 1, which doesn't have 5 doesn't have any right subtree. Yeah, this is this. 5 doesn't have any right subtree. Then 1 to the left, and then on to the and the right subtree of 1 will have 4, which will have left subtree 2, and so on. So it is inserted correctly. Okay. So that is how we insert something. Now, how do we? Somebody tell me how do we do a pre-order traversal? Let's do an in-order traversal. Who is going to help me in-order traversal? I'll just share the code in Piazza so that you will be able to do the in-order traversal right away. Yeah, I have copied to Piazza. So how do we do in-order traversal? Yeah. Define in order of tree will be somebody. How do we do in order? What should I write here?
You should first check if the tree is null.
Null tree. In that case, I should just
Give nil.
but we can print the tree. No, so we don't need to print something.
Okay. I thought we will accumulate the thing in a list and then we'll return the list.
Okay, that's also possible. All right, so let's do that. Null tree nil. Otherwise,
Otherwise, we'll call append of in order of left subtree of tree, then root of then list of root of tree, and then again in order of right subtree of tree.
in order of
LS of
of tree and
list root tree.
um, this root tree. So I'll just cons here. Yeah, I'll cons of root tree and
Nil or okay.
in order of
Oh, okay. A right subtree of RSF.
right of tree. Okay. Let me call this tree sample tree. So in order of sample will be one, two, three, four, five. That's correct because in order traversal should give me a or sorted list. Okay, so that's how you do in order traversal. Now, how do we find the depth, height of the tree? Height of the tree. If the tree is empty, then it has height 0. Otherwise,
Max of
yeah. By the way, what is height of a tree? Somebody tell me what is height of a tree. Somebody other than Saina. Jaswant, can you tell me what is height of a tree? Shashwat, what is height of a tree?
So depth of the deepest node or the deepest leaf node.
Yeah, that's of the deepest leaf node. Yeah, that's a valid definition. Yeah. So now if I want to compute the height of a tree, what should I do? If the tree is empty, then I know that it has height 0 because it has no leaf, no node altogether. So it's 0. Otherwise, what should I do?
So otherwise, we have to keep on traveling left subtree
Yeah.
or
So I have to compute the height of the left subtree, height of LS of tree.
and height of the RS subtree, and we can take max of those.
Yeah, but I should add 1 to both. Yeah, because there is a root. So I take the height of the left subtree, I add 1 to it, or otherwise I could do another way also. I could add 1 at the end. I take the height of the left subtree and I compute the height of the max right subtree, and I compute the max. Is there a function called max? Max 4, 5. Yeah, there is a function called max. And then I add 1 to it. So height of sample will be 5. Is that true? This is a tree 1, 2, 3, 4. So I think 1, 2, 3, 4. The height of this tree should only be 4. So I'm adding 1 here. So uh, that's because this tree should have height 0. This small tree, which contains 5 and 1, should be height 0. But the way we are computing, this tree will have height 1. How can we do so that a tree of this height have height 1?
Sir, instead of going to null, we could return 0 when we have only one node left, right? So we could just check whether both the children are null.
Yes. So let's have a function called define leaf tree. And what should it check? Null of and of null of left subtree and null of right subtree. And here I say, if the tree, this I'm going to replace with a cont, and I'm going to say if the tree is null, then it has height 0. If the tree is leaf, then it has height 0. Otherwise, now sample has height 4. Yeah, is that clear what we did? Okay, now complicated. Let's try to do some exercises here. Check if all the leaves are at the same level or at the same depth. Check if the tree is the mirror of itself. What do you mean by mirror of a tree? So if I take a tree like this, if I take a tree like this, mirror will be what? Here it will be, you replace every level, you put a mirror and reflect. That's what is mirror mean.
It's 11 o'clock.
Yeah. So 5 will be the root. Then 5's left subtree is 1, but so therefore 5's right subtree in the mirror should be 1. One's right subtree is right child is 4, so one's left child should be 4. 4's right child, left child is 2, so the right, it has to be right child, and so on. Yeah. So this is what mirroring means. So if how do we so the second question is that check if the tree is a mirror, if the tree the mirror of itself. Okay, on in other words, if it is closed under exchanging the left and right children, that's what it means. Yeah. Okay, those are the two questions. Now so this is how you code tree functionally, in the sense that there is no assignment statements, there are no set q, there are no set char, set cadder, nothing. Now how do we do it using, how do we use it, do it using states? So this is trees functionally. Now what we should do is that trees with using assignments. Yeah, how do we do that? Is using assignments. Hello. How do we so let's start with we will use the same thing, but now what we can do is that we will use the same car, cadder, all these things, but insert tree we can write it using states. Or let's say yes, insert.
So won't the make tree function change?
Make tree function need not change now. It will, it is just creating a node. One second, let me just think.
So it's
But
returning the created node or the tree. It's not modifying V.
let's imagine I have a tree. Define tree, which originally I have to start with a tree, and that tree has to be a tuple. No. So I will always assume that there is a one particular node which is called the root node. Okay, so that will be something like define tree. Then let's call it T. Define T to be, which contains a tag no. One second. Help me here. What should be my tree using assignments? Assignments.
Maybe in the make tree only, you can actually give a tag in front of.
So I'll always assume that my tree at least contains one node. Yeah. Because otherwise all trees are the same. Because I can't say that my tree is empty. So I'll always assume that my tree will always contain a root node. Okay, so I have a make tree function. Yes, make tree. So that will, what does it do? It just list with a node X, list of X and nil and nil. Yeah. So this will be my tree. So now if I create define T tree 0. So this will be a tree which contains 0 at its root. Okay, see, or just some other value, any value is fine. Okay. Now, if I want to, whenever I come here, yes, insert, I want to insert to this tree, and I'm not returning anything. I'm returning this T itself. Okay. Now, how do I insert something to, let's call it T. No, T tree. How do I insert a value X into S insert tree X? What should I do here? How do I insert here? I mean, anyway, all the inserts happens at the leaf node. So all I have to, so I don't have to check that if the tree is empty, because if the tree is empty, then I'm always assuming that my tree contains at least one node. Or I can also check if the tree is empty. Yes. Null of tree. So if tree, then I can Yes, make tree. Yeah. Now what do I do? No, this is not how you do it. No, this is not how you do it. Somebody tell me, how do we insert? I have a tree T. This tree is pointing to a tree. Now, how do I insert something to the, how do I insert some, I have to traverse down the tree, and I always need to have a parent. And I have to change.
So we can make set left subtree and set right subtree.
Set left subtree and set right subtree. Okay. So what should our S insert function return?
So it won't return anything. It will just put X inside the tree.
Yeah, but it will be better if we return the original tree T, no? Won't it be a good idea? Otherwise, all right. So let's go with let's run with Devyani's idea that it doesn't return anything, even though it's not a good idea not to have such functions.
So, but returning would just mean adding the tree at the end of it, like just returning the function of what it's got after it's inserted.
Yeah.
So effectively, it's not doing anything in terms of
It's not doing anything. Yeah, that is true. That is true. But it's also a personal preference. But there are so many list functions which doesn't return anything. I mean, things which don't return something, that is very common in the object oriented world. Yeah, because most methods don't return anything, they just cause side effects. But in the functional world, everything returns, because the idea is that you don't cause side effects, so you just transform things. Yeah, so it's yeah. I mean, right now, did anybody feel that writing trees functionally was easier than writing trees using assignments? Right? Is more difficult than writing trees using assignments? At least somebody felt that way.
Yeah.
Yeah. So, I mean, if you feel that way, then I am partially successful. Yeah, because when we start learning programming using C, that is, first of all, C is a very low-level language. When we start doing programming using C, one of the thing which it does to our brain is that it makes it very natural, because we learn the hard way to think in terms of how the underlying machine model is. Yeah. But actually, when you think about it, what is natural is the functional way, but what is unnatural is doing things using assignments. It's highly unnatural, but it takes some bit of practice with the functional world that you feel that it is highly unnatural. Now you see that if we want to insert an element into a tree, what we have to do is that we have to chase down. We have to start with the root. We have to chase down till we meet a point where what is to be inserted is on a subtree which is empty, and then we have to change that particular node char or color. Yeah, that is what is happening. Yeah. Okay, so I'll give you as an exercise. This is exercise 3. write the function yes insert 3x that inserts the value x into the tree. Is the question clear to everybody? Hello? Hello? Okay, so please do these 3 exercises. And for the next week, can you do, yeah, so we didn't summarize what happened in the environment model. Next week, we will do environmental model, that lecture 13. As well as object-oriented programming 13 and 14 for Monday. And I will also have a quiz next week. Okay. Sometime next week. Okay, so do the exercises and lecture 13 you have already read, 13 and 14. And yeah, so sometime next week there will be this one also. Okay. Thank you.
Thank you, sir.
Bye.
Sir, when are we going to have the mid-semester exam?
So I don't know. I don't like to have mid-sem exam with a lot of marks, because that gives you, unless there is some because we don't have proctoring tool, no. So what is your opinion? Should we have a midsum or a quiz in its place? One thing is that I am really not satisfied taking an exam without any proctoring tool, because that gives you an added incentive of copying. Hello. So discuss with the class, Siddharth.
Yes, sir.
So discuss with the class, and the MTechs also can discuss. I am of the opinion that we should have quizzes, only quizzes. So we have 2 quizzes so far. We'll have some 3-4 more quizzes going down the line, and we'll make, that is what the dean also advised. Instead of having midsum, to have small quizzes. And after this, I'll give you one assignment, so that you can submit as code. Yeah, once we finish this. And if we quickly finish this list part, we can go on to some other stuff. Okay. All right. So see you next week. Hello.
Yes, sir.
So thank you, sir.
Yeah. Thank you.
Thank
Bye.
you, sir.